Okay, we're on to Unit 2, 2-1. It's all about graphs and functions and things like that. Got a lot of different types of problems in this packet. None of them take very long to do, okay? So we see this table for miles traveled in gallons. We need to write an equation for the table. This is the independent variable m. This is a dependent variable g. To write an equation, you need an equals. You start with g, okay, your dependent variable. Now what's g start at? 11.2. Okay, easy enough. G equals 11.2, wherever it starts, okay? Then what I like to do is always put a plus sign, okay? And then I like to make a ratio line, okay? I'm going to have a numerator and denominator. We'll figure out those here in a second. And then after the ratio line, I like to put a parentheses because it's dependent upon the variable m. So g starts equals 11.2 plus a ratio times m. Let's figure out the rate of change is what that's known as, okay? Now we started with our g right here, okay? We're figuring out the g. So find out what g changes by every time. Here's how to do that. Start at the bottom of the table and then subtract. Change means subtract. So 8.2 minus 9.2, negative 1. Makes sense, it dropped 1 from here to here. 9.2 minus 10.2, negative 1. 10.2 minus 11.2, negative 1. Negative 1 is your numerator, okay? Now, the denominator, I come over here. 51 minus 34 is 17, positive. 34 minus 17, 17, 17. So every time that goes down 1, which is negative, that goes up by 17. And that's your answer. Now, sometimes this can be divided, but leave it, if it's a decimal, we're just going to leave it, okay? See, I don't want to write that. That's a decimal, so we're going to leave it in fraction form. So again, g equals 11.2 plus a ratio, a rate of change, multiplied by the m variable, okay? That's the answer. Now to check your answer, you can substitute one of these random numbers for m. Let's go 34. So I'm going to punch in 11.2 plus negative 1, ABC 17. And I'm going to, instead of m, I'm going to put 34 in. Now this better be 9.2 when I plug it in. It is, okay? Let's say I pick 51. Instead of 34, I pick 51. Okay? So 51. 8.2, okay, same thing. This is the answer. And that doesn't take long, but you got to know how to do it. And this, the dependent unit over here needs to be your numerator. You can't put 17 over negative 1. It's got to be this over this. Okay, tell whether the function is linear or nonlinear. Here's how to tell this. It's all about your y's. The x's are always going to be 0, 1, 2, 3. So 14 minus 11 is 3. 11 minus 8 is 3. 8 minus 5 is 3. Then it's linear because it changes, the rate of change is constant. 72 minus 12 is 60. 12 minus 6 is 6. 6 minus 2 is 4. That's non-linear. Easy enough there. Now, I know nobody likes graphs, okay? But I want you to graph this function using a table. X, Y. And we can put anything for x that we want, okay? X is independent. I like to start, there's no rhyme or reason to what I'm about to do, but I'm going to start 0 in the middle, then 1, 2, negative 1, negative 2. That's how you should do it. So y, well, y equals 2x minus 4, so I write that out. 2x minus 4, 2x minus 4. Then I'm just going to substitute a 2 over the x. It goes in for x, but I just put it there. So I have 2 times 2 minus 4, which is 0. 2 times 2 is 4, minus 4 is 0. Then I put a 1 in. 2 times 1 is 2, minus 4 is negative 2. Put a 0 in. 2 times 0 is 0, minus 4 is negative 4. Then 2 times negative 1 is negative 2, minus 4 is negative 6, and I think you think the last one's negative 8. That's a linear function, okay? Now to graph it, this is x, this is y. You should know that from Algebra 1, x, y. So x is 2, y is 0. So I go 2 to the right. You don't need to number your graph, okay? You shouldn't have to do that at this point, okay? Go to 2, and then you stay there. So that's 2, 0. You can label it if you want. You don't have to put that there if you don't think it's necessary, 2, 0. Then when I put 1 in, I got -2. So I go forward 1, down 2. On x, positive means forward, negative's backward. On y, negative means up, or negative is down, positive's up, okay? That is 1, -2. You don't have to label it if you don't want. 0, -4. So if x is 0, I don't move forward or backwards from the origin, down 1, 2, 3, 4. -1, -6. So I go backwards 1, down 1, 2, 3, 4, 5, 6. -2, -8, I go backwards 2, down 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then I'm going to take a ruler and connect them, okay, because I can put decimals in for x2. Decimals are between the whole numbers, so it's continuous, okay. It's a continuous function, linear function. That's all you have to do, okay. Now, you're going to look at these graphs, and you're going to tell whether the graph, actually, hold on a second. I'm going to come back to this. If it makes sense out of that, I want to start here. Identify the domain range of each relation. Tell whether the relation is a function. So first I write domain range. I didn't do much of this in Algebra 1 2 years ago, but it's really easy. They're all xy coordinates. The x's represent your domain, so -2, 0, 4.6, or no, 4, that's a 6.5, that's hard to read, and 5. Okay, then 0.5, range is your y's, 0.5, 2.5, 6.5, and 2.5. Now, here's how you tell whether it's a function. You either write function or not a function. It's all related to the domain. You don't pay any attention to the range. Do any of the numbers repeat themselves in the domain, or are they all just there one time? They're all just there once, so we have a function. I don't care that I have 2.5s in the range. It's all about the domain. I can't emphasize that enough. So domain equals, for the next set of coordinates, range equals. Okay, so the domain is 6, 4, 6, 5. The range 5, 3, 4, 8. Remember, I pay attention to the domain. Okay, that set of numbers there. And I have repeats with the 6's. So since I have repeats, then it's not a function. Okay, now we're going to go back to the graphs and decide whether these graphs are functions, okay? It's known as the vertical line test. No, you don't need to label all the coordinates. You can if you want, but you're wasting time. A quicker way is the vertical line test. By the way, all coordinates, I mean, like that's backwards 1, 2, 3, 4, 5. So -5, 1, 2, 3, 4, 5, 6. So -5, 6 is that coordinate, okay? But there's an easier way. Vertical lines go straight up and down. If I go through that point, that's the only point I go through. This one went through 3 points. If any of the vertical lines you make go over more than 1 point, you can stop because that's not a function. And the reason why it's not is because all these coordinates have an x of -2. So that's 3 coordinates with an x, a domain of -2. You can't have the repeats. Okay, so you make vertical lines. There's 1, but there's 3. As soon as I do that with more than 1, not a function. Okay, next problem. Line, line, line. Okay, I'm going through 1 at all times, so that's a function, okay? There's no repeated points with the vertical line test. Now, I have actually 2 graphs here because I didn't want to make another paper, okay? Is there anywhere on this U here that I can make a vertical line and cross the U more than once? No, you can't, because I mean right there it crosses it once, right there. Right there it crosses it once. That's impossible. So this U represents a function. Now let's look at this one. It's like a sideways U. Now, if I make a line there through it, I crossed it twice. So that's repeats, so not a function. And that's how you do the vertical line test. Because those are continuous graphs. These are known as discrete graphs because there's no connection. These are continuous. Okay, let's keep it rolling. The volume remaining in a 243 cubic foot pile of gravel decreases by 0.2 cubic feet with each shovel, S of gravel spread in a walkway. Write a function to represent the situation. It's easy. V is the dependent variable. It starts at 243. You don't need a table, okay? Then it decreases by 0.2 cubic feet with each shovel, S, okay? Now, if you made that a ratio like I did on the very first problem in this video, it would just be over 1. Well, having a denominator over 1 is pointless, okay? So that's it. V equals 243 minus 0.2 times S. Okay, probably the most annoying one's the next one. You have to list the domain and range from a story problem. I want to buy limited edition coins for $22 each. Coins and dollars are in italics. There's a limit of 8, so again, dollars, coins. There's a limit of 8 coins for a customer. Find the domain and range of the relationship. Is a function continuous or discrete? So I have to find the domain, the range, and then I need to answer a question, okay? Okay, make a table, an XY table. Coins and money. Money has to be Y. Coins is X. And then with your X, just go 0, 1, 2, and we'll go 3. So if I buy 0 coins, I'm not paying any money. If I buy 1 coin, that's $22. Now I want you to put a times 22 with that 1. Forget about the 0. If you buy 2 coins, that's $44. Because 2 times 22 again is 44. If I buy 3 coins, I'm up to $66. 3 times 22 is 66. Now you can stop there. Now this continues on, okay? Now there's a limit. The limit is 8 coins. So to find what goes with the limit of 8, you take 8 times 22. And you get 176. So the domain your X is 0 to 8. Just put 0 dash 8. Then the range is from 0 to 176. And that's your domain and range. Now you have to answer this question. Continuous or discrete? Here's what that means. Pick a decimal. Let's go between the 2 and the 3. Let's put 2.5. Is it possible to go to a store and buy 2.5 coins? No, it's not, okay? So decimals are not possible here. And if decimals are not possible, then the graph is known as discrete. If they are possible, it's continuous. So instead of coins, if that said hours, well, you can do 2.5 hours. So that would be continuous. But this is coins. When you're buying something, you only buy it by the full amount. Unless it's like by weight, okay? So it's new, and this is the answer I'm looking for here, okay? Okay, next problem. Evaluate each function for the given value of x and write the input x and the output f of x as an ordered pair. You've never seen this before, but it ain't hard. You get this thing f parentheses x, that's called f of x. F of x equals 17x plus 3. I'm going to replace the x's with 4, so f parentheses 4 equals 17 parentheses 4 plus 3. Now forget that f parentheses 4 a second. You're going to go over here and do your operations. You would times first, that's 68 plus 3, And then 68 plus 3, I just keep dropping f for 71. Now here's how you have to write the answer. Ordered pair looks like that, 471. That's the input, that's the output. Pretty easy. Now we do the same thing. This is now it gets repetitive. 2 parentheses 9 minus 33. Just drop the f of 9. There's no operations there. 2 times 9 is 18 minus 33. 18 minus 33 is negative 15. So I want 9, negative 15. That's the answer. Okay, now I'm going to put 3 in for x. F of 3 instead of f of x. It's just a different notation. You haven't seen it before. I didn't do it in Algebra 1. 7/3. I think you did it at Aurelia. This is one thing I skipped over. So I'm going to multiply 7/3 times 3, which is going to be 7. And then subtract 9. 7 minus 9 is negative 2. Then f of x equals 11x minus 11. X is negative 11. So f parentheses negative 11 equals 11. Negative 11 minus 11. Okay, so I got f of negative 11. I need to multiply these two. 11 times negative 11 is negative 121, and then I subtract 11. That's going to be negative 132. Okay, so I write negative 11, negative 132 as my answer. Okay, last problem. That's the end of the video. Probably going to want to look back at stuff. Write a function rule to model the cost per month of a long-distance cell phone calling plan. Get plane out of there. It's plan. Then evaluate the function for the given number of minutes. Now the monthly service fee is $4.52. The rate is 12 cents per minute. The minutes used is 250. I've already kind of taught you how to write a function rule, to be honest with you. This is how you write a function rule, okay? So you got dollars and minutes. Those are both in italics. Now, I usually use X and Y. You could also use M and C for cost, but I usually go X and Y. So per, dollars per minute. Dollars per minute is 0.12 times X. So on my XY table, I've got minutes and dollars. So 0, 1, 2, goes on. Now before this 12 cents per minute, we paid $4.52. Then I add 12 cents, 464, and then 476, and that goes on. Okay. So my line began at 4.52 plus 0.12 times X equals Y. So that's basically your function rule. 4.52 plus 0.12 times X equals Y. Now there's a bunch of ways you can write it, okay? Since you could also write it 4.52 plus 0.12. Instead of X, you could use M. And Y is money. Usually you use cost for that, okay? That's a function rule, okay? You can write it as that. You can also have the C come first. Or you can have the Y come first. You can also turn it around. You can always turn an equation around. But that's what I'm rolling with. Now be careful. 250 is the minutes, okay? So you will not be putting that in for Y. It will not equal 250. You simply substitute it in for the independent variable X. X equals 250. Okay, so 4.52 plus 0.12 times 250 equals Y. Now I don't have to get rid of things, okay? Because the Y is by itself. I need to just multiply, go over here and do my operations. First multiply, because 0.12 cents a minute times 250 is 30 equals Y. 452 plus 30 is $34.52. These are the answers I'm looking for in this problem, okay? That and that, okay? Those two things. Or you can write 3452 is for sure the second answer. Or you can write that instead of the X and the Y. Go with what you're comfortable with.